Welcome to Physics 1 Engineering Practical classes. Our first experiment is force table. The prerequisite for this experiment is scalars and vectors. A detailed video about these scalars and vectors is available on YouTube. Just type scalars and vectors by Abdul Ghaffur. The objective of this experiment is to find the resultant of two forces and to verify the obtained experimental values with the algebraic method. The apparatus consists of the force table, frictionless pulleys, strings, slotted masses, hangers, and a circular ring. Let's see a quick setup of this experiment. Here, the force table should be kept on a horizontal surface. So we can see here there is a mark which is very important to note down the position of the pulley. So pulley 1 is kept. Now pulley 2. Is fixed. Now this is the third pulley. So this is our initial setup. Let's find the resultant of two perpendicular forces experimentally. So here, say this is pulley 1. Say it is at 0 degree. On pulley 1 we apply some force, say 1 Newton, and at pulley 2, which is at 90 degree, here also we apply a force of 1 Newton. And from these two forces, first we will find the balancing force, okay, and then the resultant force. Let's get into the experiment.
Let us calculate the resultant of two forces experimentally. Let's take the simple case. Take the forces, two forces as 1 Newton and 1 Newton, and that two perpendicular forces. So let's start. Okay, so three pulleys are here. Okay, take this one as the first pulley, this is the second one, and this is the third pulley. Keep the first pulley at 0 degree. Let's make it simple. So there is a mark here. This should be at 0. Fix it. Now this is pulley 2. Keep it at 90 degree. Exactly. Okay, so this pulley 1 and pulley 2 should be at fixed positions. Okay, first of all, okay, let this be okay. So this is the third pulley. This is, we will be adjusting its position, so let's not bother about this position. So this is the first pulley. It should be at 0 degree. Here then the nylon thread here, okay, initial adjustment should be like this. So ring should be in the middle, okay. The thread on the pulley 1 should be at 0 degree. So here this is on 0, this is also on 0, not 0. So I have to adjust its position first. 0, 0, and then this should pass through this part in the middle, okay. This position, okay. Now this should be adjusted. Let's check. From the top we have to observe. Then only we get accurate results. 0, 0, and this is passing through this center. Similarly, the second one also, the nylon thread is passing through. Here it is 90, and the thread should be on the again on this line 90, and it should pass through this center like this, okay. And we don't disturb these two the knots of the knots, right? So let's apply the force here on pulley 1, F1. So let's take 100 gram. 100 means it will produce 1 Newton force. Okay, 1 Newton force. Now on pulley 2 here, for this also apply 1 Newton force. That is, we have to keep now. So 1 Newton here, 1 Newton here. So these two forces pulling the ring to that side, okay. So we have to bring the ring in the center to the equilibrium position, okay. So for that we have to apply some force here on this pulley, so that it will balance these two forces, okay. First of all, adjust its position, because it is looking for me this line is not passing through the middle, so the angle should be from here. First we will adjust its angle, okay, roughly. This is all trial and error method, okay. So it's looking nice, okay. This position, I'm fixing this position around 220 like this. Now apply some mass on it. I will start with 100 gram. So 1 Newton force is applied. Now look at here. So it is not balancing these two forces, this one. So we have to apply more force, more mass. So 100 is already kept. Let's keep 150. That is, add 50 more. Yes. So it is more now. Okay. This force is pulling the ring to this side. So decrease, remove 50 and keep 40 and check. So 20 is less, not sufficient. One more 20 plus 20, 40 is added. The 40 is less only. Okay, some more. 150 we already added, so I would like to take this 5 grams, so total it become 145 becoming little more. So instead of 5 I will go for 2 gram. Yes, it's almost okay, but the angle, not happy with the angle, so I want to move this. Oh, slowly. Now I can see that all the forces, this one is passing to this point, center point, even this one is passing, all the, so angle is okay. So it is at an angle of this is around 220, it is exactly in between 225, the same 225 is passing, so exactly perfect. This is in equilibrium position. Now almost okay, but I want to add slightly, I would like to add 1 gram. Yes, it's perfectly in the center. So here we applied 1 Newton force. So here let's check how much this part is. This is okay, I will remove it. 100 gram, 120, 140, 142, 143 gram altogether. Okay, 143 gram means 1.43 is the magnitude of this balancing force. This is the balancing force. Okay, so from the force table we find this one, the balancing force. Okay, our experiment is from this balancing force we have to find the resultant force, resultant of these two forces. So resultant of these two forces lies between somewhere here. Okay, we know very well that when it is 0, 90 degree, one is at 0 degree, one is at 90 degree, and they are equal, 1 Newton, 1 Newton. In this case, obviously the resultant will be in the middle, 45 degree, that we know it. Okay, let's, okay, so about this one, this is the balancing force. Okay, let's convert this balancing force into the resultant force. Very easy. Okay, we got the magnitude equal to 1.43 Newton. So the same magnitude it will have, the resultant force, which is here. The direction, just you subtract whatever the number is here, 225 minus 180 degree, exactly opposite. Okay, so here the balancing force is acting from here to here, this side, whereas the resultant force will be acting here, this way, opposite to the balancing, this way, 180 degree. Okay, so here at 45 degree, this is the resultant of these two forces. Okay, understood? Like this we find the resultant of two forces experimentally. Okay, so first we will take the random values, whatever we want. Okay, we apply the forces on these two pulleys. We have to find the resultant of these two forces acting here. Okay, which we get it by the balancing force. Always whatever degree is here, we always subtract 180 degree. For example, here 220. 225 minus 180 degree, so which is equal to 45 degree. So here at 45 degree, so the resultant vector is acting. This is the resultant vector. Magnitude, very simple. Magnitude, look at here, how many grams are there? Okay, how many grams are there? Divide with 100, it will be converted into newtons. Very simple. Understood? Okay, so like this we can take anywhere. You can take the force here, another force here. Okay, accordingly we get the answer, resultant. Okay, all the best.
We have done the experiment. Okay, let's complete the observation table. So this is for pulley 1. This part consists of again 3 subparts. This is pulley 2. This is for pulley 3. So pulley 1, we know at pulley 1 we put a mass of 100 gram. So convert the gram into the mass into the force, mg formula. So in short you can say that simply wherever gram is there, divide with 100, it will be converted into Newton. Simple trick. So here at pulley 1 we are applying a force of 1 Newton and the pulley 1 is kept at 0 degree, whereas pulley 2 same 1 Newton force is applied. Okay, the angle, the position of pulley 2 is 90 degree, and at pulley 3, this is the pulley 3 where we are getting a balancing force. This is the balancing force, so it is balanced by 1.43 Newton. This 1 Newton, 1 Newton which are kept at 90 degree apart, so it is balanced by one force, that is the balancing force, that is having a magnitude of 1.43, and the position of this balancing force is at 225. Okay, our objective of this experiment is to find this one. This is our resultant force. Very simple. So whatever the magnitude we got here, 1.43, the same one. The direction is simply whatever here we are getting 225 degree, just subtract 180, so the answer is 45, exactly 45. So this is all by experiment from the force table. Let's check our obtained values, the magnitude and direction of the resultant vector with the known mathematical, that is algebraic method. So here we have taken a component of vectors technique. So here very simple. Okay, the force F1 is acting along the x direction, so along the x direction, so we take it completely 1 Newton, whereas it is completely along x axis, so no component along the y axis, so 0. Now let's focus on the force F2 which is acting completely along y axis, so it won't have any component along the x axis, so this is 0, this is 1. Okay, whatever it may be. So for the resultant force we have to add all the x components, 1 plus 0, 1. Similarly we have to add all the y components, 0 plus 1 which is equal to 1. So these are the two rectangular components of this resultant vector. So we want the magnitude of this resultant vector, so which we obtained by square root of fx square plus fy square, so 1 square plus 1 square which is equal to 1.414 Newton. Whereas the direction of this resultant vector is also obtained by these two components, that is y component by x component, that is shift tan. So we got it 45. Let's compare. So this is the magnitude of the resultant force by our algebraic method, component technique, 1.41. Okay, we are getting 1.4, just okay, almost close. These two are matching. Similarly the angle, nice, it's perfectly matching, 45. Like this we do the experiment. So let's go. This time we will find the resultant of two vectors. This time there will be some angle between these two vectors. Okay, so here this is pulley 1, this is pulley 2, this is pulley 3. So pulley 1, okay, it is kept at 30 degree now and 1 Newton force is applied, whereas the pulley 2, it is at now 150 degree, whereas 1.5 Newton is applied. Let's see how much we have to get here at pulley 3.
Okay, so this is going to act as pulley 1, this is pulley 2, and this is pulley 3. Okay, so now the pulley 1, in this case the pulley 1 is at 30 degree. Whereas pulley 2, we are going to keep it at 150 degree. Okay, now we don't bother about pulley 3, we will change its position by trial and error method. So on pulley 1 we are going to apply 1 Newton force. 1 Newton means 100 grams. Okay, so pulley 1, which is at okay, yes, before that I forgot to adjust the strings. Okay, before that we have to keep the ring in the middle, and pulley 1 is at 30 degree, so the string should come here from 30 degree to on this 30 degree, and we have to adjust its position. It's okay, 30 also here, 30 also here. Now pulley 2, keep it in the center, 150 degree, so adjust its position also. Check now. So 30, 30, 150, 150. So these two positions are fixed. Okay, about this pulley we will see afterwards. Okay, let's first apply exactly 1 Newton force we are going to apply here by keeping 100 gram on pulley 1. Done. Now on pulley 2 we are going to apply 150. So 100 plus 50, 150 on pulley 2, which is at 150 degree. Okay, 150 gram, 150 degree. Nice matching. Okay, now look at here. The ring is not in the center. Our aim is to bring it at the center. Okay, equilibrium position. Now these two forces are more, so that's why this ring is dragged that side. This side no force is applied. Let's apply some force here, just by trial and error method. Keep 100 gram here, that is 1 Newton force. Keep it here. Okay, so here not balanced. It seems that the angle is not okay. This side it is going more, so shift it to right side, right side, right side, right side. Now it is looking okay. This is okay now. So now let's apply. So we have applied 100. This is one more 50. 150 is added. Okay, once again I repeat. The pulley 1 is at 30 degree, where we kept 100 gram mass. Here pulley 2 position 150 degree, 150 gram is kept. Okay, 1 Newton, 1.5 Newton. Okay, now we have to balance these two forces. Okay, so far we applied 100 here. Now I'm going to apply one more 50 grams. So 1.5 Newton is applied. Yes, this 1.5 is more now. Okay, this part is more compared to these two because it is pulling this side. So what we will do, we remove 50 from here and less one. We apply instead of 50, keep it 20 and check. No, 20 is very less. So let's keep one more 20. One more 20. Now this is more. So instead of 20, I would like to keep 10. So yeah, somewhat okay. It is in the this side, but I'm not happy with the direction. I want to check once again. This is, we kept it at 30, 150, but this side it is showing okay 190. I want to, no, 190 is not okay. Okay, it is just 1 degree less, 289. Not bad. I will apply some more mass. Okay, 2 gram I am going to apply. Let's see. Now 2 gram is little more. Instead of 2 gram, I will go for 1 gram. 1 gram. Yes, this is looking good for me. But still I am not happy with this direction. Yes, now it is 288. 288. Here also 288 almost. Yes, I am happy with this position. Now it is at the center. Okay, this is the balancing force. This is force 1, this is force 2. These two are balanced by this force. This is the balancing force. So we know the balancing force is at 280 and 285, 6, 7, 288. 288 degree. Now let's check how much mass we put. This is 100. This is 20, 120. This is 10, so 130. 131 gram mass. 131. So 1.31 Newton. Okay, let's go to our calculation part. Let's see how much our computer is giving the answer. Okay, I can see that yes, 1.32. We can see that 1.32 at 109 degree. Okay, this is the resultant. Actually this part is the resultant vector, but from the force table we don't get directly the resultant vector, we get the balancing vector. Okay, just subtract here 288 minus 180 degree, so which is equal to 108. So we are almost close. Okay, and the magnitude we are getting 1.31, but our calculation is giving 1.32, so almost okay. It's good. Understood how to find the resultant vector using the force table. All the best.
Let's see the calculation part. Pulley 1 Newton at 30 degree. At pulley 2 1.5 Newton is applied, which is at 150 degree. Now we got the force at pulley 3, that is the balancing force of magnitude 1.31, which is at an angle of 288. So from this balancing we convert it into the resultant force. So same magnitude 1.31, whereas the direction always we subtract minus 180 degree, so which is equal to 108. Now let's go to our component method. Okay, we will check how much the component method is giving. Okay, let's check whether we are close to these two or not. So here component method very simple, so focus on this part. So F1, okay, so resolve this F1, this is our F1. Resolve this F1 along x-axis and along y-axis. Resolve into two components, fx, xy. So okay, x component for this F1 is f cosine theta, that is equal to 1 cos 30, which is equal to 0.866. Now the y component is just sine theta, okay, 1 sine 30, okay, so which is equal to 0.5. Now focus on this force F2, resolve it into the x and y component. For x component f cosine theta, whereas the y component f sine theta. So this time the angle is 150, keep it here, automatically our calculator will give the corresponding values. For this minus 1.3, for this 0.17. Okay, now let's calculate the resultant of these two forces, F1 and F2. We are directly calculating the resultant force. So what we have to do? First we will calculate the component of this resultant force just by adding these two. Okay, x components we are adding. So this is positive 0.866 and this is minus 1.3. So our answer is minus 0.434. In the same way, the y component is obtained by adding these two, so which is equal to 1.25. So these are the x and y components for this resultant force. So in the component method, okay, to find the resultant force from these two components, simply the formula is square root of fx square plus fy square. So fx square is okay, so we have to take only positive value, no need to worry about the negative here. So 0.434 whole square plus 1.25 whole square, which is equal to 1.32. So yes, the magnitude is almost matching, 1.3, 1.3, just small changes in the decimal. Okay, so agreed. Now for the direction, very simple, tan inverse of the y component divided by x component. Remember, we have to take only the positive. Okay, don't take the negative value here. So positive values are taken. So then our calculator give us as per the reference angle, which is in the second quadrant. Minus, x component is minus, y component is positive. So this is in the second quadrant. We have already learned that, okay, whenever in the second quadrant we are getting, we have to just subtract 180 minus this value, so which is equal to 109 degree. So yes, we are in terms of the direction also we are close. Okay, our theoretical the algebraic method is giving 109 degree, our experimentally we got 108 degree. Easy. Thank you.